Practice Test 1. Listening section. Directions.
This section tests your understanding of conversations and lectures. You will hear each conversation or lecture only once. Your answers should be based on what is stated or implied in the conversations and lectures. You are allowed to take notes as you listen, and you can use these notes to help you answer the questions. In some questions, you will see a headphones icon. This icon tells you that you will hear but not read part of the lecture again. Then you will answer a question about the part of the lecture that you heard. Some questions have special directions that are highlighted. During an actual listening test, you will not be able to skip items and come back to them later, so try to answer every question that you hear on this practice test. This test includes 2 conversations and 4 lectures. Most questions are separated by a 10-second pause. Listen to a conversation between a student and a professor.
Ted, did you get my email?
No. I actually haven't had a chance to check my email yet today. Sorry.
Well, I just wanted to see if I could have a quick word with you after this class.
Well, the thing is, Professor, I'm working on the campus newspaper, and I need to get over there right after class for a meeting.
Well, this won't take long. Let's just chat now before class starts.
Sure. What's up, Professor Jacobs?
Well, next week, the students in my graduate creative writing seminar are going to be reading aloud from their works at the student union.
Yeah, I saw a poster about that on the bulletin board down the hall.
Yes, well, anyway, Ted, I'm also inviting a few students from my undergraduate class to take part, and I'd like one of them to be you, if you're willing.
Me? Seriously? I don't know what to say.
Well, just say you'll do it then. The reading will be in the ballroom of the Student Union at noon next Friday.
You know, I'd really like to read the first 2 or 3 chapters of this novel I've been working on.
I was thinking that you could read some of your poems. In fact, I didn't even realize that you were writing a novel. What's it about?
It's about the commercial fishing business, about working on a fishing boat.
Really? Do you know a lot about that topic?
Well, I grew up in Alaska, and my grandfather owned a fishing boat, and I worked on it one summer. Plus, my grandfather told me a million stories about fishing. Of course, I've changed the stories some and fictionalized all the characters.
I was hoping you'd read that poem about spending the night alone in the forest. What was it called? Northern Lights, I think.
That poem? Huh. When I read it in class, you didn't say much about it at all. So I figured you didn't much like it.
Well, I wanted to hear what the other students in class thought of it. But yes, I quite liked it. The language was very strong, and in particular, I found the imagery powerful, almost a little frightening.
How about this, then? I'll read just 1 chapter from the novel. The first one's pretty short. And then a couple of poems as well. Will that be okay?
I think that should work. Drop by my office sometime this week, and we'll figure out which poems you should read.
Okay. And Professor Jacobs, thanks. I'm really flattered that you'd ask me to take part.
Now, get ready to answer some questions about the conversation. You may use your notes to help you. Question 1. Why is Ted unable to meet with Professor Jacobs after class? Listen again to part of the conversation.
Yes, well, anyway, Ted, I'm also inviting a few students from my undergraduate class to take part, and I'd like one of them to be you, if you're willing.
Me? Seriously? I don't know what to say.
Question 2. What does Ted mean when he says this?
Me? Seriously? I don't know what to say.
Question 3. What is Ted most interested in reading aloud next Friday? Question 4. Which of the following can be inferred about Professor Jacobs? Question 5. Why does Professor Jacobs ask Ted to come to his office? Listen to a conversation between a university administrator and a student.
Hello, Financial Aid Office. Connie Fong speaking.
Hi, Miss Fong. My name's Dana Hart, and I'm a second-year student. I'm just calling to see if I can get some information on the work-study program.
Sure, happy to help you. What would you like to know?
Well, what are the requirements for...
The eligibility requirements? Okay, first off, are you taking at least 60% of a full-time academic load?
Yeah, 100%. I'm a full-time student.
Okay, that's fine. Then let me ask you this. Are you qualified to receive financial aid?
I have no idea. I'm not getting any financial aid now. See, I have a personal bank loan to pay for my tuition, and my parents are helping me out with my room and board expenses. But I really have no money for living expenses, so that's why I'm hoping to land a part-time job.
Well, you'd need to fill out some financial aid forms to see if you qualify. It depends on your level of income and on your parents' level of income.
So if I fill out these forms and I don't qualify for financial aid, then there's no way I could get a work-study job?
No, that's not necessarily true. You see, there are two kinds of work-study positions. There are needs-based positions. Those are the ones funded by the government. And for those, yes, you have to qualify for financial aid. But there are also what we call merit-based work-study positions. These positions are available regardless of financial need, as long as the financial aid office determines that a work-study position helps you meet your educational goals. If it's a useful supplement for your formal classes, it's even possible that you could earn academic credit for some of these positions.
So what sorts of positions do you have open right now?
Well, it depends on your interests, your experience.
The only job I've ever had, I worked in a restaurant, but I don't want anything in food service, food preparation, no cafeteria job.
Well, we try to find you jobs related to your educational goals. Say, for example, if you're studying biology, we might try to place you as a technician in a biology lab.
I'm an art major, and I was wondering, are there any jobs in the art gallery at the student union?
Hang on a sec. No positions at all at the student union, but, okay, here's a position at the Metropolitan Art Museum. It's as a tour guide there.
Really? Wow, that sounds fabulous. But I thought work-study jobs were all on campus.
Oh, no, about 25% of all our positions are off campus. They're positions with foundations or organizations that we think perform some worthwhile community service.
So how many hours a week is this job?
I'll check. It looks like they want someone there for around 20 to 25 hours a week.
Really? I don't know if I could put in that much time and still do okay in my classes.
Well, don't give up on the position for that reason. You know, we really encourage job sharing, 2 students working one position. It's possible that we could arrange something where you'd only work about half that much time.
That sounds more like what I had in mind, 10, 12 hours a week or so. So what do I do to apply for this job?
Well, the first step is to fill out the financial aid forms I mentioned. You can come down and get them from the receptionist at the front desk, or you can fill them out online if you like. Then I'll call the contact person at the museum. Let's see. Oh, okay. It's Dr. Ferrara. He's the personnel director at the museum. I'll call him and set up an interview for you. And you understand that he's the one who makes the hiring decision, not anyone in our office, right?
Sure. Okay then. Thanks a lot for all the information. I'll get those forms from your website and send them back to you this afternoon or tomorrow.
Now, get ready to answer some questions about the conversation. You may use your notes to help you. Question 6. Why does Dana want a work-study position? Question 7. What can be inferred about merit-based work-study jobs? Question 8. Which of these work-study positions does Dana express the most enthusiasm for? Question 9. What must Dana do first to apply for the position that she is interested in? Question 10. Why does Ms. Fong say this?
Well, don't give up on the position for that reason.
Listen to a lecture in an anthropology class.
Okay, class. We've been talking about traditional types of shelters, about the styles of houses used by traditional people. And today I'd like to talk a bit about the homes of the Inuit people, the Eskimos, the people who live in the far north in the Arctic regions of North America. Now, all the Inuit used to have two types of houses, summer houses and winter houses. Their summer houses were called tupik, and they were originally made of animal skins and later canvas. There were various types of winter houses, though. The Inuit who lived in northern Alaska, where there was plenty of driftwood, built their winter houses from wood they found on the shore. The Inuit who lived in Labrador, that's in northeastern Canada, now, they built their winter houses from stone and earth and supported them with whale bones. It was only in the north-central part of Canada and in one place in Greenland that the Inuit built their winter houses from snow. Oh, and by the way, the Inuit who lived up in Greenland, in a place called Thule, they were some of the most isolated people in the world. Until sometime in the early 19th century, in fact, they thought they were the only people in the world. Imagine how surprised they were the first time they met outsiders. Anyway, when the first Canadians of European descent arrived in northern Canada, and they saw these houses made of snow, they asked what they were called. The Inuit replied, igloos. And so that's what we call them now. In English, the word igloo means a dome-shaped house made of snow. However, it turns out the word igloo in Inuit just means house, any sort of house, a house of wood, a house of snow, whatever. How did the Inuit make these snow houses? They used knives made of bone or ivory to cut wind-packed snow into blocks. They arranged these in a circle and then kept adding smaller and smaller blocks in a rising spiral until a dome was formed. Then they'd pack the cracks between the blocks with loose snow. A skilled igloo builder could put up a simple igloo in a couple of hours. And you know what? He could do it in a blizzard. The igloo was the only dome-shaped traditional housing that was built without internal support. It didn't need any interior support because it was so strong. The bitter Arctic winds caused the outside of the igloo to freeze solid. Then the interior was set with a seal oil lamp. What I mean is, they used these lamps to melt a little bit of the snow blocks, and then the water refroze into ice. So you had a layer of ice on the outside of the dome and one on the inside. And like I say, it was strong. In fact, it would support the weight of a man standing on top of it. Igloos were remarkably warm inside. I mean, Given that they were made out of snow, they were surprisingly cozy. Snow is actually a good insulator, believe it or not, and it keeps the intense cold out. Igloos were usually small enough so that body heat warmed them up pretty quickly. The Inuit slept on platforms of packed snow covered with furs. Oh, and the entrance tunnel to the igloo was dug out so that it was lower than the igloo floor, and cold air got trapped in the tunnel. Seal oil lamps were usually used to heat igloos, so there had to be a hole at the top of the dome to let out stale air and smoke. If igloos were to be used for a fairly long time, they naturally tended to be more elaborate. Sometimes circular walls of snow were built around igloos to shield them from the wind. Sometimes these walls were even built into a second dome around the first one, and the layer of air between the two domes provided even more insulation. These semi-permanent igloos had windows and skylights made of freshwater ice or translucent seal gut. And sometimes you'd have clusters of igloos. They were connected by tunnels. Sometimes 5 or more Inuit families lived in these clusters. And sometimes the Inuit built larger snow domes that could be used more or less as community centers. You know, the nights are long up there in the Arctic, so they needed some entertainment. They held dances and wrestling matches and their famous singing competitions in these larger igloos. In the early 1950s, the Inuit began living in permanent year-round housing. They only used igloos when they went on overnight hunting trips. Today, they don't use these wonderful snow domes for shelter at all, not even as temporary housing. But sometimes they'll build igloos for special exhibits, and sometimes you'll see little igloos in their yards that they build as playhouses for their children.
Now, get ready to answer some questions about the lecture. You may use your notes to help you. Question 11. The professor mentions 3 types of winter houses used by the Inuit. Match these 3 types of houses with the locations where they were used. Question 12. Why does the professor say this?
Oh, and by the way, the Inuit who lived up in Greenland, in a place called Thule, they were some of the most isolated people in the world. Until sometime in the early 19th century, in fact, they thought they were the only people in the world. Imagine how surprised they were the first time they met outsiders.
Question 13. What can be inferred about the word igloo? Question 14. In this lecture, the professor describes the process the Inuit used to build a simple igloo. Indicate whether each of the following is a step in the igloo building process. Question 15. The professor did not mention that larger igloos were used in which of these ways? Question 16. According to the professor, what did the Inuit do in the early 1950s? Listen to a discussion in an astrophysics class.
Excuse me, Professor Fuller?
Yes, Mark.
You just told us that it's impossible to travel faster than light.
Well, that's according to the theories of Albert Einstein, as I said. And who am I to argue with Einstein?
So that means... Well, doesn't that mean people can never travel to other stars in spaceships?
Well, let's think about it. How fast does light travel?
Wait, you just told us. Let me find it in my notes. Okay, 186,000 miles an hour.
That's miles per second, Mark. 186,000 miles per second. Almost 6 trillion miles per hour. And how far is it to the nearest star?
I think you told us it's 4 light years.
It's a little more, but that's close enough. So think about that. Moving at 6 trillion miles per hour, it takes about 4 years to get to the closest star. And of course, we can't travel anywhere near as fast as light. A couple of years ago, the Voyager spacecraft left our solar system, and it was traveling faster than any man-made object ever. And you know what? It would take Voyager 80,000 years at that speed to get to the closest star.
Wow. If you brought along sandwiches for the trip, they'd get pretty stale before you arrived, wouldn't they?
No doubt they would. Now, of course, Voyager isn't accelerating. It's just coasting. It's traveling through space like a bullet that was shot from a gun. What you need is a ship that can constantly accelerate and keep increasing its speed. Clearly, rockets won't work.
What's wrong with rockets?
I think I know. They couldn't carry enough fuel, right?
Right. It takes an enormous rocket full of fuel just to lift one of the shuttles into Earth orbit. You could never carry enough to get to another star. Even if you used nuclear-powered engines, you just couldn't bring enough mass.
Professor, I read an article about a spaceship that used sails to propel itself through space.
You couldn't use sails in space. It's a vacuum. No air.
No, Liza's right. These aren't conventional sails, of course. A scientist named Robert Forward came up with this idea. He said you could launch a ship with rockets and then unfurl these giant sails made of thin plastic. I mean, many square kilometers of thin plastic sails. Then you fire intense bursts of laser beams at the sails, and since lasers travel at light speed, pretty soon you're scooting along at close to the speed of light.
I thought it was a brilliant idea.
There's a catch, though.
What's the catch?
Well, you'd still need huge amounts of fuel to power the lasers, more than you could carry. No, to reach the stars, you need some revolutionary drive system that requires little or no fuel.
Is anyone even working on something like that?
As a matter of fact, yeah. There are teams of some cutting-edge physicists who are looking at things like anti-gravity, antimatter, artificial wormholes, things called negative mass and zero-point energy, as possible ways to power ships. But these concepts are all in the speculation phase.
What do you mean they're in the speculation phase?
Well, any workable technology goes through at least 4 phases of development. There's the speculation phase. That's where you figure out what your need is and dream up a system or a device that can fill that need. Next is the science phase, where you basically do experiments and see if the technology you dreamed up might possibly work. After this comes the technology phase. You bring in the engineers, tell them what you need, and they build it for you. Finally, you put the technology to work. That's the application phase. But all these technologies that I mentioned, they're just in the speculation phase.
Okay, Professor, let's say, for the sake of argument, that scientists dream up a way to travel half as fast as light, and engineers manage to build it. Then it would only take about 8 years to get to the nearest star and 8 years to get back. Isn't that just a 16-year trip?
Well, possibly. But 4.2 light years is the distance to the nearest star, not to the nearest star with planets. We don't know if any of the stars in our immediate neighborhood have planets. Suppose you went all that way and just found empty space. The closest star with planets, at least with Earth-like planets, may be much farther away.
Professor, I thought you said that these days scientists could detect planets around other stars.
Well, yes, that's true. I did say that. There have been hundreds of what are called extrasolar planets discovered. But if you remember, I said that almost all of them are huge planets, gas giants, a lot like Jupiter probably. And a few that were discovered recently are smaller, rocky planets, but they are very close to their stars, closer than the planet Mercury. We still don't have the know-how to detect Earth-like planets. Maybe the closest Earth-like planet is dozens, even hundreds of light years away.
Well, Professor, I guess you're saying that we'll never be able to visit other stars. I just think that's too bad. I love science fiction books and movies, and I always hoped that people would one day be able to whiz around the galaxy the way people travel around our planet today.
You know, Mark, I don't think that trips to the stars will be practical unless we develop a way to travel faster than light, or close to that. And I don't think that will ever happen. So, I don't want to rule out anything. Who knows what kind of scientific breakthroughs we might have in the future. But Mark, I don't think I'd pack my bags and head for the spaceport anytime soon.
Now, get ready to answer some questions about the discussion. You may use your notes to help you. Question 17. What is Professor Fuller's opinion of Albert Einstein? Question 18. What powers the sails on the ship that the class discusses? Question 19. According to Professor Fuller, what must be developed before ships can travel to the stars? Question 20. Professor Fuller discusses the process by which a new technology evolves. Summarize this discussion by putting these 4 steps in the proper order. Question 21. What does Professor Fuller say about the planets that have so far been discovered around other stars? Listen again to part of the discussion.
You know, Mark, I don't think that trips to the stars will be practical unless we develop a way to travel faster than light, or close to that. And I don't think that will ever happen. So, I don't want to rule out anything. Who knows what kind of scientific breakthroughs we might have in the future. But Mark, I don't think I'd pack my bags and head for the spaceport anytime soon.
Question 22. What does Professor Fuller imply about travel to other stars when she says this?
But Mark, I don't think I'd pack my bags and head for the spaceport anytime soon.
Listen to a lecture in an art class.
Morning, class. Okay, so today we're going to continue our study of 20th century art with a discussion of photorealism. This style of art, it was also called hyperrealism or superrealism. It was popular in the late 1960s and the 1970s. Painters who worked in this style, they portrayed their subjects down to the smallest detail, and so their paintings look like photographs. They resemble photographs in many respects. Now, you have to keep in mind that at this time, in the 60s and 70s, art was dominated by minimalism and conceptual art, which were very non-representational types of art, very abstract. And so this incredible realism was kind of a reaction to that. Okay, I'm going to show you a slide of a painting by the photorealist Audrey Flack. It's called The Farb Family Portrait. When she painted this, she used the same techniques that a lot of photorealists used. First, she took a photo of the family. Next, she drew a grid on her canvas, dividing the whole surface of the canvas into little squares. Then, she made a slide from the photo and projected the picture onto her canvas. One by one, she systematically painted what was projected onto each of the little squares. Each square was really its own tiny work of art. Audrey worked with an airbrush and she used acrylic paints. The acrylic paints account for the bright, luminous colors that you see in most of her works. In fact, most photorealist paintings tend to be bright and colorful. So, where did this style of painting come from? You might say, what's the big deal? People have been painting realistically for hundreds of years. The Dutch masters were obsessed with getting details right. And in the 18th century, there was a European school of painting called trompe-l'oeil, and painters who worked in this style were as interested as photorealists in capturing every detail of what they saw, in making their subjects look real. However, these painters were also interested in creating optical illusions, three-dimensional optical illusions. The phrase trompe-l'oeil means trick of the eye. For example, one of the paintings from this school pictures a boy who appears to be climbing out of the painting, climbing right out of the frame. That's not one of the interests of photorealism, creating optical illusions. Anyway, what sort of subjects did the photorealists paint? Photorealists painted still lifes, portraits, landscapes. Although there are not many paintings of rural scenes, mostly they show urban scenes. The subjects of photorealist paintings are interesting only because they are just so ordinary. One photorealist, the painter Chuck Close, once said the subjects of his paintings were so normal that they are shocking. Another one, a painter named Richard Estes, said, "I don't enjoy looking at the things I paint, so why should you enjoy it?" What he meant there, I think, is that the technique of painting is the important thing, that the subject itself means little. How one painted was much more important than what one painted. In a little while, when we look at some more of the slides I brought, you'll see typical photorealist subjects. There's one of a gas station, one of an elderly man waiting at a bus stop. Let's see, there's one of an old closed-down drive-in movie. Weeds are growing up between the speaker stands and the screen is practically falling down. Some painters specialized in painting one type of subject. Richard Estes, for example, liked to paint urban scenes, ordinary city sites reflected in sheets of window glass. For example, he might paint a parking lot reflected in glass or a drugstore reflected in big plate glass windows. There was one photorealist who only painted neon signs and one who painted only trucks. The point is, photorealists never chose grand, inspiring subjects to paint. They always painted ordinary, everyday, banal subjects. Now, I'm going to show you another slide. This picture was taken at the museum where Dwayne Hanson's works were on display. Looks like a photo of the museum security guard, doesn't it? That's what a lot of the visitors to the museum thought too. They would come up to the guard and ask him questions. But this isn't a photo of a flesh and blood person. It's a photo of one of Hanson's sculptures. Hanson was a photorealist sculptor. He fashioned human-sized statues of people from plastic. He then painted them to make the plastic look like human skin, and he added hair, clothing, shoes, jewelry, sometimes props. One of his sculptures features a man riding on a lawnmower. Again, his subjects were ordinary people, a car salesman, a homeless person, a student, a child putting together a puzzle. As you'll see in a couple of minutes, all of these statues are as realistic as this one of the security guard. Okay, as promised, I'm going to have a little slideshow for you. While you're viewing these works of photorealistic art, I'd like you to take notes on what you think of them. Then, over the weekend, I'd like you to write a short paper, really short, just a page or two, that describes your reactions to these works.
Now, get ready to answer some questions about the lecture. You may use your notes to help you. Question 23. What does the professor say about minimalism and conceptualism? Question 24. Which of the following did Audrey Flack not use when painting the Farb family portrait? Question 25. How does the professor explain the subjects that photorealists painted? Question 26. Which of the following would Richard Estes most likely choose to paint? Question 27. According to the speaker, why are the sculptures of Dwayne Hansen so remarkable? Question 28. In this lecture, the professor gives a number of characteristics of the photorealistic school of painting. Indicate whether each of the following is a typical characteristic of paintings of that school of art. Listen to a discussion in a meteorology class.
Afternoon, everyone. So, in our last class, we talked about thunderstorms. Today, I want to talk about a similar phenomenon, hailstorms. Anyone here ever been caught in a hailstorm?
As a matter of fact, last year, I was driving home from the university one weekend. My parents live about 70 miles from here, and the sky got really dark, and it started to rain. And then, all of a sudden, it was like little pebbles were pounding on the car, and there were balls of ice as big as marbles bouncing around on the highway.
So what did you do, Mike?
Well, as soon as I could, I pulled off the road and parked under a highway bridge until the storm was over. But it was too late. I had lots of little dents in my car.
I remember when I was in high school, there was a bad hailstorm, and it wiped out my parents' garden. They were really upset because they love gardening.
Well, that's interesting, those two examples you gave, because every year hailstorms cause more than $1 billion worth of damage. And you know what? By far the most damage is done to vehicles and plants. Not gardens, really, but farmers' crops.
There's nothing farmers can do? Can't they cover their crops with plastic sheets or...
No, there's no practical way to protect crops, although farmers can buy insurance against hail damage. Now, back in the 14th century in Europe, farmers tried to ward off hail by ringing church bells, banging on pots and pans, and firing cannons. Hail cannons were common in wine-producing regions, at least through the 19th century. And in the Soviet Union, as late as the 1950s, the government used cannons to shoot silver iodide crystals into clouds. This was supposed to make the hailstones smaller so they wouldn't do as much damage, but it didn't really work too well.
Professor, do they get hurt by hailstorms very often?
Hurt? Well, it doesn't really seem like it to me. Sometimes you'll hear about a person stuck up in a Ferris wheel or some other ride at an amusement park being injured or something like that. But it doesn't seem to happen very often, does it? And it's kind of surprising, isn't it, considering that hailstones can be as big as baseballs, sometimes even bigger, and can travel like 100 miles an hour. So I don't really have any statistics about that, but I'll try to get some information. Okay, now, another question. Has anyone ever cut a hailstone in half to see what it looks like? No? No one? Well, what do you think it would look like? Penny?
Well, I don't know. I suppose it must look like a little snowball cut in half.
No, as a matter of fact, it looks more like an onion cut in half. Lots of layers. And what does it usually mean when you find layers in something? Mike?
Well, I guess that it wasn't formed all at once.
Exactly. Here's how you get hailstones. A hailstone starts off as a droplet of water in a cumulonimbus cloud. That's a thundercloud. Then, remember last class we said there were a lot of strong updrafts of warm air and strong downdrafts of cold air inside a thunderstorm? Well, one of these updrafts picks up the droplet and lifts it high into the cloud where the air is cold and it freezes. Then, because of gravity and cold downdrafts, it falls.
Professor, wouldn't it melt when it falls? I mean, when it gets into the warmer air?
Yeah, when it hits the warmer air at the bottom of the thundercloud, it might start to thaw. But then our little half-frozen droplet gets picked up by another updraft, carrying it back into very cold air and refreezing it. This happens again and again. With each trip above and below the freezing level, the hailstone adds another layer of ice. Eventually, the hailstone gets so heavy that the updrafts can't lift it anymore, so it drops out of the cloud and bingo, you've got hail.
So, Professor, you said that you only get hail when there's a thunderstorm. Is that right?
Well, hail only forms in cumulonimbus clouds, which are the only kind of clouds that generate thunderstorms, though you don't always get thunder and lightning when you have hail.
Sometimes I've seen on weather reports you get a lot of hail just before tornadoes.
Well, that's true, but hail isn't always associated with tornadoes, and not all tornadoes are accompanied by hail.
So if you just look at a thundercloud from the ground, can you tell if you're going to have hail?
No, not just by looking, but a meteorologist can tell by using Doppler radar. Doppler radar can look inside a cloud. Okay, we said thunderstorms are most common in summer. How about hailstorms? When are they most common?
I'd guess in the winter.
Nope, afraid not.
The hailstorm I was caught in was in April, maybe early May, so I'd guess spring.
You're right. And the part of the United States where they're most common is along the Rocky Mountains, in Colorado, Wyoming, Montana. In fact, the most costly hailstorm in U.S. history was in Denver, Colorado. Just that one storm caused over, I believe it was about $750 million worth of damage.
Now, get ready to answer some questions about the discussion. You may use your notes to help you. Question 29. According to the professor, which of the following are most often damaged by hail? Question 30. According to the professor, which of these methods of preventing damage from hail was used most recently? Listen again to part of the discussion.
Professor, do they get hurt by hailstorms very often?
Hurt? Well, it doesn't really seem like it to me. Sometimes you'll hear about a person stuck up in a Ferris wheel or some other ride at an amusement park being injured or something like that. But it doesn't seem to happen very often, does it?
Question 31. What does the professor mean when he says this?
Hurt? Well, it doesn't really seem like it to me.
Question 32. Why does the professor compare a hailstone to an onion? Question 33. At what time of year are hailstorms most common? Question 34. In this lecture, the professor describes the process by which hail is formed. Indicate whether each of the following is a step in that process.
This is the end of the listening section of Practice Test 1. You may take a 10-minute break. Speaking section. Directions.
This section tests your ability to speak about various subjects. There are 6 tasks in this section. Listen carefully to the directions and read the questions on the screen. The first 2 tasks are independent speaking tasks. You have 15 seconds in which to prepare your response. When you hear a beep on the audio program, you will have 45 seconds in which to answer the question. The last 4 tasks are integrated speaking tasks. The third and fourth questions involve a reading text and a listening passage. You have 45 seconds in which to read a short text. You will then hear a short conversation or part of a lecture on the same topic. You may take notes on both the reading and listening passage. You will then see a question on the screen asking about the information that you have just read and heard, and you will have 30 seconds in which to plan a response. When you hear a beep on the audio program, you have 60 seconds in which to answer the question. The fifth and sixth questions involve a short listening passage. You may take notes as you listen. After listening to the conversation or lecture, you will see a question, and you have 20 seconds in which to plan your response. When you hear a beep on the audio program, you have 60 seconds in which to answer the question. During actual tests, a clock on the screen will tell you how much preparation time or how much response time, speaking time, remains for each question. It is important that you time yourself accurately when you take this practice test. On an actual test, your responses will be recorded and evaluated by trained raters.
Question 1. Please listen carefully.
What is the most important decision that you have ever made? Give specific details and examples to support your explanation. Please begin speaking after the beep. Now, stop speaking.
Question 2. Please listen carefully.
In some university classes, grades depend mainly on tests, such as quizzes and final exams. In other classes, grades depend primarily on academic papers that the students write. Which type of class would you prefer to take? Give specific details and examples to support your explanation. Please begin speaking after the beep. Now stop speaking.
Question 3. Please listen carefully.
Lincoln University is instituting a new policy regarding requirements for graduation. Read the following notice from the Dean of Education. You will have 45 seconds in which to read the notice. Begin reading now. Now listen to two students discussing this notice.
So, I guess it's back to the language classroom for us. Have you, given any thought about what language you're going to study?
Well, I think I could probably get at least an 85 on the placement test for Japanese because,
Oh, that's right. You used to live in Japan, didn't you?
yeah, my dad worked for a Japanese company and my family spent a year and a half there when I was in high school. I took classes and I had a lot of Japanese friends, so I got to be fairly fluent.
Lucky for you. I studied Spanish in high school, but, well, my teacher wasn't a native Spanish speaker, and all we did was memorize grammar rules. I didn't really learn much of the language, to tell you the truth. No real point in my trying to take a test. I'm just going to start over.
Well, I am too. I kind of agree with what the regents are saying. You gotta be able to speak another language these days. I don't think you can understand another culture without speaking at least a bit of the language. And if you want to work abroad or even just travel, you need some fluency in another language.
So, what language are you going to study?
Well, I think I should learn a European language, just for balance. Probably French or Italian.
The woman gives her opinion of the notice written by the Dean of Education. Explain her opinion and discuss the reasons she gives for having this opinion. Please begin speaking after the beep. Now stop speaking.
Question 4. Please listen carefully. Read the following passage about airships. You will have 45 seconds in which to read the passage. Begin reading now.
Now listen to a discussion about airships.
So, how many of you were at the football game on Saturday night? Quite a few of you, huh? Did you happen to look up and see something in the sky? Yeah? What did you see?
A blimp.
Right, a blimp. It was the blimp Columbia. You'll see the Columbia and other blimps at sporting events and other big gatherings. What are they used for, mostly?
To, carry television cameras so they can show what things look like from above, I guess.
Right. Aerial photography and...
And advertising. A lot of times they'll have electric signs on them advertising something.
Right. Now these, blimps you see today, they're descendants of the Zeppelins that were built in the first part of the 20th century. Most of them were built in Germany. Not all, but most. These Zeppelins were huge, over 250 meters long. What were these airships used for?
I don't know. Didn't they carry passengers?
Right. There was regular passenger service on Zeppelins, even transatlantic service. They could travel amazingly long distances. They were also used for military purposes in World War I. Okay, I'm going to show you a picture, a very famous picture. What's happening in this picture?
That's the, what's it called? The Hindenburg disaster.
That's right. This happened in 1937 in Lakehurst, New Jersey. There was an explosion and a terrible fire on the German Zeppelin Hindenburg, and 35 passengers and crew members lost their lives.
What caused it, Professor?
No one knows for sure, although there have been lots of theories. Anyway, this tragedy pretty much ended the age of the giant Zeppelins, at least until about 10 years ago. That's when a German company started building Zeppelins again. We'll talk about that in our next class.
The professor and the students discussed two airships, the blimp Columbia and the Zeppelin Hindenburg. Using information from the passage and the discussion, compare these two airships. Please begin speaking after the beep. Now stop speaking.
Question 5. Please listen carefully.
Listen to a conversation between two students.
Hi, Diane. Getting ready to go somewhere for spring break?
Hey, Mike. No, this year I guess I'll just hang out on campus. I was going to go see my sister in Boston, but, well, I waited too long to make an airline reservation. The only tickets available are way too expensive for me.
Why don't you just drive to Boston?
I thought about that, but it's at least a 20-hour drive, so I'd have to stop somewhere and get a hotel room. And gas is so expensive these days. Driving there would be almost as expensive as flying, and I'd be exhausted when I got there.
Hey, you should go check the ride board over at the Student Union building.
What are you talking about?
You've probably seen it, you just didn't realize what it was. Basically it's a map of the United States, divided up into regions. And for each region, there's an envelope hanging on the wall. If you have a car, you fill out a blue card saying where you're going, when you're leaving, how many riders you can take, and so on. You put it in the envelope for the region where you want to go. For New England, in your case. If you don't have a car, if you're just looking for a ride, you fill out a white card. Usually riders share the gas expenses and sometimes the driving. I used the ride board and found a guy who wanted to ride to San Francisco last summer. It was a lot cheaper and easier than traveling alone.
Okay, so I should fill out a blue card since I have a car.
Right, well, you could fill out both. That way if someone else was driving there, you could go with him or her.
Well, I guess I should give it a shot. A lot of students are traveling at this time of year.
Hey, I just had another idea. You might also think about taking a train.
A train? I never think about taking trains. It seems kind of, old-fashioned somehow. Although in Europe, I rode some of those high-speed trains, and those were great.
Yeah, well, the train to Boston won't be high speed. It will take quite a while to get there, but you can sleep and study or whatever on the way. And taking a train, I don't know for sure, but I think it's usually a little cheaper than flying. Probably not all that much cheaper, though.
Okay, well, I suppose I could look into that too. Thanks for the suggestions, Mike.
Mike offers Diane 2 possible solutions to her problem. Discuss her problem and then explain which of the 2 solutions you think is better and why you think so. Please begin speaking after the beep. Now stop speaking.
Question 6. Please listen carefully.
Listen to part of a lecture in a botany class.
Okay, we were speaking in our last class about pollination, about how all flowering plants have to be pollinated. I said then that the most common method of pollination was by bees, butterflies, and other insects. These insects visit flowers to get a sweet liquid called nectar that the flowers produce. This is their source of food. It just so happens that these flowers, these nectar-rich flowers, are also fertile and are ready to pass on their pollen to other plants by means of these insects, or they could also receive pollen the insect has picked up from another plant. Now, for most plants, this process is pretty much hit or miss. It's pretty random. Insects have no way of knowing which flowers contain nectar and pollen, so they have to visit a lot of flowers to find the right ones. However, there are some plants that have a system that tells the insects which flowers to visit. It's based on a color code, believe it or not. For example, there's a plant, a shrub called the lantana, and on the first day it blossoms, its flowers are yellow. That day, the flower is full of pollen and nectar. The next day, the flower turns orange. There's less nectar, less pollen. On the third day, it turns red and it's no longer fertile. It has no pollen, no nectar. Only about 10% of the lantana's flowers are yellow at any one time, but insects are 10 times more likely to visit a super fertile yellow flower than a less fertile orange one, and nearly 100 times more likely to visit a yellow one than an infertile red one. And this system, it's a good deal for both plants and insects. Insects have to visit fewer flowers, and plants do not have to expend energy trying to keep all their flowers full of nectar and pollen all the time. Now, you might say maybe it's something else. Maybe it's the smell of the nectar and not the colors that provide the signal to the insect. But no, there were experiments done with flowers made of yellow paper, and insects were as likely to visit these as real flowers. So no, it's the color. Any questions about this?
Using specific examples and points from the lecture, explain the relationship between the lantana plants and insects, and discuss how it benefits both of them. Please begin speaking after the beep. Now stop speaking.
This is the end of the speaking section. Go directly to the writing section. Writing section. Take 3 minutes to read the short passage that follows. You may take notes as you read. After 3 minutes, turn the page and start the audio program. You will hear a lecture on the same topic as the reading. Again, you may take notes as you listen. You will have 20 minutes to write your response. Your response should include information from both the reading and the lecture. Your essay will be rated on the completeness and accuracy of your response, as well as on the correctness and quality of your writing. A typical response should be 150 to 225 words.
Listen to part of a lecture in a psychology class on the same topic that you just read about.
Okay, everyone have a chance to read that little piece I gave you about risk-taking personalities? It comes from an article in a journal published, maybe 70 years ago. The author takes a pretty harsh view of risk-taking, doesn't he? Today, most psychologists take a somewhat more tolerant view of many types of risk-taking than psychologists did then. Sure, some people are natural risk-takers and others are risk-averse. But I can't go along with this article when it says there's a universal risk-taking personality. Some people take risks in one part of their lives, but not in others. An investment banker might always buy safe stocks, but then he might race motorcycles on weekends. The article discusses the connection between risk-taking and suicidal tendencies. Well, I'd argue that most risk-takers tend to be pretty confident that nothing bad will happen to them. They recognize that their activities are dangerous, sure, but because of their skill, their positive attitude, their experience, they will succeed. Motorcycle racers don't think they will have accidents no matter how fast they drive. The article suggests that there's no reward for people who take unnecessary risks. Actually, there are rewards. For one thing, there's a physical reward, a chemical reward. What I mean is, when people take risks, when skydivers, say, jump from airplanes, their bodies pump chemicals like adrenaline into their bloodstreams. For some people, this is pleasurable, something to repeat over and over. There are also psychological benefits. Studies have shown that risk takers have higher self-esteem, higher levels of confidence, more social and financial success than those who don't. Now, I don't want to make any blanket statements about taking risks. There are some risks that people shouldn't take. Smoking is a health risk, one that's just foolish to take. But we psychologists have changed our opinion since this article was written. We realize that sometimes it's important to take risks, and that risk takers aren't mentally ill.
Now get ready to answer the question. Remember, you may turn the page and look back at the reading passage. You may also use your notes to help you. You have 20 minutes to prepare and write your response. Question. Summarize the main points made in the lecture that you just heard, discussing how they cast doubt on the main points of the reading. You can refer to the reading passage as you write.
This is the end of the Integrated Skills Writing section and of the audio program for Practice Test 1.